Hey everyone, welcome to the stream. So, since last stream, there's one of my viewers, Pyro ESP, who sometimes on stream here. He got in touch with me. Hey, this gamer, things are good. So yeah, so Pyro got in touch with me, and he had watched the last stream and had noticed my struggling with understanding how the comparator bit gets set with respect to the joystick potentiometers, and so he decided to look into how it actually works at the hardware level. And yeah, it was actually really quite enlightening. He basically explained to me something that I didn't quite understand, and it totally makes sense now that I see it. That basically the way it actually works is, so I had this code here where I lazily update the comparator bit when we try to read the value for port B, which I think actually is fine given that our joystick values that we get are something that we update once per frame, and we only really care about the analog state when we read port B because it sets this comparator bit. So I'm still okay with kind of doing it lazily, but my original condition, which was like this, was saying if the mux is enabled, if it's not enabled, then we read. And the reason I thought that this was the case was because I thought that, erroneously, the way I imagined things working was that you have this multiplexer, and it's connected to the integrators that are used for drawing, and I thought at the same time it's connected to the joystick potentiometers for the 4 axes, the 2 axes per joystick. And I thought that this mux enable was kind of like a selection of which of the 2 sets of 4 things it's connected to, but it turns out that doesn't make any sense. And in fact, what it is that this is actually a mux demux chip that we're talking about, and for the potentiometers it's actually the demux that we care about. And it's always basically pulling the values for the joystick, but it's connected to the joystick pots, but if the mux is enabled, then the value for the current potentiometer is what gets connected to the bit of circuitry that compares that value to the DAC value and sets the comparator bit. So that's always happening. And actually I kind of like how I have here this paste bin or haste bin that Pyro sent me to kind of help me understand what it's doing in terms of if you look at it from software's perspective. And so yeah, basically what he's got here is he's saying, the DAC value is whatever is on port A, so that's pretty much what I have as well. But then here he's saying if the mux is enabled, then we set this potentiometer value to the selected mux input for the joystick. And then after that, this part continuously is executed on hardware. So we always set the compare bit based on this updated or refreshed pot value. So all that to say is that if the mux is disabled, the comparator just kind of is using an old, a stale pot value and comparing that to the DAC. I say stale or old, I mean like the last version of the last value that was there, and it gets refreshed as long as the mux is enabled. So I was thinking about how I want to handle this. I could still kind of handle it this way, although technically speaking, maybe it's not 100% accurate, I guess. Let me think for a sec. No, I guess this should be fine. But basically what it means is I should be just inverting my logic here. It's if the mux is enabled, and actually somebody who also watched my stream since has, and I don't have the name in front of me, but another viewer actually mentioned the same thing at that moment in my video, said, shouldn't it just be mux enabled? And yes, I guess that makes perfect sense here. Let me just think here. Is there a case where this doesn't make sense? Yes, that is the issue with my car driving off center. So I actually fixed this last time by just ignoring the mux enable and just always reading, but actually always reading isn't correct either. See, I had written this to-do list here, this to-do to understand what's going on. But basically it's the other way around. It's if the mux is enabled, we want to make sure to set the comparator to be the comparison. I guess what's not quite accurate here is I should be always setting it, and what I would need to know is, like, it's more like if the mux is enabled, then I grab the current joystick analog state. Otherwise, I kind of have to remember what was the last one. So technically, that's what it would be. So if I want it to be really accurate, I don't know how much it would matter, to be honest, at this point. But if I wanted to really emulate the hardware, that's sort of what it would be. So if I wanted to do that, I might need to move this into like update or something. But I mean, it's probably okay to just do it this way. The only difference would be like, what would, you know, if the code ever were to read that bit while the mux is disabled, then technically speaking, it wouldn't be exactly correct. So like, for example, say the mux is not enabled, right? So this code here would never run if we use if you use this example here, like of how it should work. Then basically the comparator bit would still be updated based on the value stored in the DAC, like what we would write to port A. So whatever like was the last, you know, value that we grabbed from the joystick, that becomes our comparison value. So this potentiometer value would be frozen while the mux is disabled. And if we keep changing the DAC, we could make the compare bit set on or off. But again, I'm not sure why anyone would ever do that, you know, in a game. I'm just wondering, because, you know, there are some advantages to doing it on the read here. First of all, by doing it on the read here, we do it only when we need to read and not every single time we do an update. Because update here will happen pretty much for every single instruction. So anything we do in here is just taking time, right? So if we don't need to do it every update, I would like to avoid it. But let's say we forget about that for just a second. How would I attack this problem to do it correctly? I suppose what I would start by doing is, let's see here. Something like, what was the value we care about here is so let's say we had this current joystick pot, then this code here would basically be that we would always set the comparator bit to be whatever is in port A signed to this pot value here. And I need the port A signed like this. Okay, and in this code, so we would, let's say, move it into the update. I don't need to do it per cycle though, so I could do at least once here. It means I might be able to get rid of this cached analog state. Now, if the mux is enabled, then the joy, what did I call it? Cur joy pod, say. Okay, mux select. Keeps its last value. Okay, so something like this. Basically, every time we update, yeah, and again, I think with this, we could actually just get rid of this joystick analog state and just use the input directly. So I'll do that if we see that this is working. No, I'll just remove that. There's no need for cur here. I'll just call it the joystick potentiometer value. So joystick pot like this. Okay, and now, and that's it. When we read and we build our value to return, it's at this moment that we do the comparator. To port A. Okay. So this would be a lot more correct. So let's see how this works. I'm also looking at the code for the digital input, wondering if I should also be moving this into the update. I'm not sure. This actually might be more correct for reading from port A though. I think it's more of a selection of what we end up reading based on some mode flags here. So this is probably correct. Okay. Succeeded. So did I have the right ROM loaded here? Well, you mean in the Vectrex Lisp Gamer? Because I mean, I'm just, I'm simulating it, right? So I just get the joystick input values. Here, let me actually plug in my gamepad here. Okay, yeah, so this is working. Which is no surprise. This should work the same way as before, but now technically we're closer to the way it's supposed to be. No, you're not supposed to clear the bit on this machine. Basically, from what I understand, that bit is just constantly being set, continuously being set based on a comparison. It's a comparator bit. So it's just always being set based on a comparison of what's in the DAC versus what is being read from the joystick potentiometers. And if the mux is disabled, then there's kind of like this sample and hold where it just holds the last value that it read from the joystick potentiometer. Yeah, so one thing that I'm reading what you wrote, Lisp Gamer. So one thing that I should make clear is that I really don't have like a background in digital circuits. So a lot of this stuff is a little bit beyond what my understanding of hardware. And in fact, I started actually reading more about this just to kind of like, round out my knowledge about this stuff, because I really don't have enough hardware, like digital circuit understanding. So, I kind of read this and I understand enough to emulate it, but when it comes down to the nitty gritty, you're talking about like discharge capacitors and stuff like that. Like I don't really know enough about that stuff, So I want to learn it. It's one of my goals. So yeah, I'm starting to read about that stuff and just familiarizing myself with it. But yeah. Oh, right, okay. That's interesting, actually. It's a little bit like timing whether or not there's a value in the CPU cache, right? To know if for that exploit there. Okay, so yeah, pretty happy with this. I'm gonna be able then to remove this joystick analog state. Okay. So yeah, Pyro ESP, thanks a lot for your help in between the streams there. It's really quite enlightening. Okay. I'm glad that's working. Now, what's next? Just looking through my list of compatibility and trying to figure out what I should tackle next. You know, obviously there's a lot of stuff here, but I want to kind of focus on something that's worth doing next. Try this test revision 4. I wonder what that does. Oh yeah. Integrator offsets. This is kind of useful, isn't it? Although I don't know what I'm supposed to be looking for. Forming checksum. Okay, so this is audio, which I haven't done yet. Focus. Just disable the blur for a sec. Like, one thing for sure is the font rendering isn't perfect yet. Oh, interesting. I thought I had made it so that it would not matter what the resolution was, but clearly that's not the case, as we can see here. Interesting. Distortion 1, distortion 2, keys and joystick. That's cool, this analog representation. Oh, that's really great. So I can really see now that the joystick is implemented correctly just from moving my, I don't know if you can see this. Yeah. This guy moves my analog stick slowly, and you can see this line here that represents the position that it believes it's at. That's pretty cool. It's quite precise. I guess this test ROM isn't necessarily using that BIOS to just check I wonder what it's doing. I wonder if it's checking like very, very precise. It's extremely precise. It must be checking like lots and lots of values. Yeah, it's extremely precise. One thing you can tell is, because my approximation, it should be from -128 to 127, but just to keep my code simple, I just went from -127 to 127, and you can see that when I go left, there's like a gap here, but when I go right, there's like almost no gap. Down, same thing. Although, yeah, I don't know why it would happen for up or for down. But really it should be right on, like we can see here. When I do left for my joystick 2, which is my keyboard that drives it, it's right there at the end of the box. Anyway, okay. Does Tour de France work? Ah, thanks, man. Yeah, I'm quite happy with the way the shader makes it look. Quite happy with that. Oh, this is cool, eh? So this is a game that also suffered from the analog problem earlier. Pause. Whoa! Which streamer? Do you know? Do you remember which streamer you were chatting with? Like, were you chatting with a streamer or just somebody else on chat? Okay, yeah, with another streamer. You don't remember who it was, by chance? A voxel village game? Is it Manifold Garden guy there? There's a guy building Manifold Garden. His game is called. Maybe that's what you're talking about. Oh, you say he's using Unreal? Okay, well, this game looks like it's working. Spectrum I+ demo. I'll just keep it small. Oh, yeah. It's tricky to see who you've seen recently in Twitch. The best thing to do is just to follow people. And once you've followed someone, you can see them in your list of people you follow, whether they're online or not. So I don't know, this ROM is constantly writing to unmapped range, which is kind of curious. That's cool. Read from unmapped range. So this ROM actually has and the value in A with immediate address 87FF, which is technically in an unmapped memory range. So if this is valid, then it means that the ROM is doing something it's not supposed to do. Just curious about some of these ones. I wonder if this one is still screwed up. I remember this one here, we had checked it out. Mountains render at first, but moving right screws up the render. So let's see, 3D scrolling demo. Oh. This looks pretty good. Okay, can we move in? No, I don't know what you're supposed to do with this one. It says 3D scrolling demo. I guess this is scrolling. So it's more like 2D scrolling. But definitely better than last time I tested it. So we fixed a lot of stuff since the last time I tested these things. A lot of CPU instructions. Oh, so that's the only thing there. Is that really all it does? Yeah, I guess so. I mean, it's cool. It's very cool that it does this. But I'm not sure why it's called 3D scrolling. There's the one that's full of invalid cartridge reads again. So let me just see why. Sorry, what are you referring to? Oh, hey, Pyro. You missed the whole part where I thanked you for for your help in between the streams there. So actually, Pyro, while you're here, since you did help me out, you're even credited in my commit here. But I'll show you what I did since you helped me out so much. So let me just pull up the diffs here. So I added the joystick pot variable to my VIA, And I got rid of this array of joystick analog state, which was a cache that I don't need anymore. And here you'll see, so in my update function, basically, oh yeah, you're right, I totally forgot to post on Twitter. Oh man, that's so true. I was running a bit late today, and I tried to, I do a whole bunch of stuff before I start the stream, you know, like I go on Reddit and I update the watch people code, and I usually remember, I update my information for the Twitch stream to update the title, and it's a whole bunch of things I go through, and then I forgot to actually say that I'm live, so sorry about that. But you know, if you follow me on the channel there and you can enable notifications, you should get an email when I go live. That's usually what I do, right? I don't know if that's something you want to do, but anyhow, so yeah, so basically in the update, what I do is, so I check the mux enable here, and if it's enabled, right, I get the mux selection, and I update the joystick pot value with the value from the joystick. So this is a value that gets kept, just like you were showing in your, I think I still have it open. Yeah, basically what you did here. You know, if the mux is enabled, then you update the pot value. And then later on, what I do is it's lazily upon read of port B, where the comparator bit is. At this moment, I set the comparator bit to the port A DAC value being less than the joystick pot value. So this port A signed is basically always the active value on the DAC. And that's it. So this basically should emulate the way it works correctly. And I was saying this, you know, based on this, if the mux is disabled, but you keep writing values to the DAC, you may, like, let's say the pot value was 0, or not, let's say it was like not 0, but let's say it was 50, right? And you disable the mux, so it holds the value 50. If you write a DAC value less than 50, the comparator bit will be unset, or if you write one greater, then it'll be set. So, or whatever. I think actually it's less than is set. Yeah, it sets it if your port DAC value is less than the joystick pot value. So anyway, so that's kind of interesting. Not that I think any games actually do that, but technically if they did, that's how it would behave. So there you go. So thanks a lot, Pyro, for that help. Yeah, no, I really appreciate it. I have tried games again. No, I mean, it's, you know, effectively what I did last time, you know, makes it work. And the reason is that, you know, I was ignoring the mux enabled flag, but in effect, the only time these ROMs, these games even care about reading those values is when they've gone through the trouble of, you know, at least enabling the mux for a bit, and then reading those values not long after. So, you know, having it be perfectly emulated was not necessary for most games to work like that. But, you know, I prefer actually doing it correctly just in case there's ever a ROM out there that does something strange. But yeah. But like, you know, if we try, what was some of those games that we fixed? Yeah, so pole position, Solar Quest, Starhawk. And another one actually that I played just earlier that was not listed there because it was not in the commercial release ROMs was this Tour de France, this bicycling game. So this one actually also uses the analog stick, and now it works correctly. So that's always fun. So I could show you. See, I can. That's pretty cool, right? So since the last stream, no, not really. Just kind of testing out different games, looking for what's the next thing I'm going to work on. Yeah, these games are pretty awesome. It's amazing the things that people were doing back then. I don't know how to actually play this game though. I don't know if I'm just supposed to press forward. Looks like I am. There seems to be, so one button seems to pause the game, and another one seems to do this kind of context-based attack depending on which direction I'm moving, which is a bit strange. This one, it would be nice to have the overlays, because all the overlays gave you, you know, which buttons you're supposed to press. This is another one that uses the analog. Which is kind of strange because honestly, like, in this game, it behaves digitally. But when I didn't have the analog stuff working correctly, it was always turning in one direction. So I guess it makes use of that function, even though it doesn't need it. I think you're supposed to collect these star things, but you can also destroy them. I don't know if collecting them gives you more points. I haven't quite figured out this game. And then there's a nuke, which it looks like to be like some kind of heat-seeking missile. Or not. It's like a missile that keeps going until it hits something, I think. Yeah. And then I have these guys that follow me. And everything is getting, like when I shoot someone, the little star that they leave behind gets sucked towards the sun. Anyway, what I like about this game is the play control. It's cool to control the ship. It has like a cool way of moving. Like you can slow down and then burst into a different direction. Like that. It's kind of fun to control. And the enemies have kind of erratic behavior as well, which makes them more interesting. So that's that one. And then the Starhawk, which that's the game I think I didn't really like because I don't really understand how you're supposed to play this game. Oh no, sorry, this is not the one I was thinking. Yeah, this one's pretty cool. Yeah, at some point I was thinking like I should start making, you know, like binary releases of the emulator available. Although right now it's like Windows only, I'd have to do a little bit of work porting it for Linux and Mac. Which platform do you run actually, Pyro? Are you on Windows? It really shouldn't be too hard for me to port this to other platforms. Okay, yeah. So you'd be able to run this on your laptop, and for desktop, for your Linux, I just have to do a bit of work. There's not too much in here that's platform specific. Everything that's platform specific is pretty much tucked away in this one file in platform. And the interface is agnostic, and then I just have an implementation in here for if Win32, and I just have this code here. And that's it. So that should take care of that. And then the other part is just making sure you have like all the dependencies, of which I have a few now, right? Unfortunately, but I have like SDL2 and SDL2net, so no big deal. OpenGL, Glue, GLM, and then there's PNG and ImGUI. So. And PNG here, this here, I can get rid of it. I do have a to-do on my list to get rid of this and make use of what's it called again? Oh, to have all this in a single file? Yeah, well this is the CMake lists, right? So I'm using CMake and I'm using find package. So I think, on Linux this should be pretty easy. You just use your package manager to grab all of these, and these should all be available through pretty much any package manager, right? Once you have them on your system, it should, like the CMake list here, should be able to find them all, and yeah. So yeah, I just need to do I did that for my NES emulator, got it working on Ubuntu actually. So yeah, I'll do that at some point. Should be fairly easy, especially because actually a lot of the platform stuff, even if they're not, I can even get away with not fully implementing most of these. Like technically set focus, set console focus, set console title. None of these could all be no ops. Even this, if we make all of, in fact, if we implement none of these, just making them do absolutely nothing. Maybe do open file dialog just so that, if you start with no ROM or want to be able to load another ROM. But even then, totally unnecessary. Most of this is for the debugger, right? To be able to break into the debugger and for it to set focus on the debugger's window and stuff. But apart from that, really not necessary. So yeah, like I said, pretty trivial to port this. I don't foresee any issues. The rest makes use of SDL, so there's nothing too magical there. There is maybe, I don't know if this ImGUI thing is going to work out of the box. I assume it would. Yeah, no, it should be fine. And anything special? My GL render? No, yeah, it looks pretty clean. So yeah, should be good. I should do that at some point, just for fun. Where was I? Let me check this 3D Mindstorm here. I wrote no boot. I think we end up hung on a black screen. Probably waiting for some bit to be set on the VIA. Okay, so when we see that we are going from 0 to F, this is where we're jumping into a BIOS routine here. Yeah, so yeah, I know, it's crazy, right? I mean, again, I'm not a hardware guy, but from everything I've read, the Vectrex is kind of an impressive system, even just in terms of how they wired it up, using very few chips to make the most out of the hardware. Apparently, it's pretty clever. Some of the tricks that were put into wiring that console up together. But yeah, it's pretty cool. And technically, the CPU, it has a 6 megahertz timer, but it's actually running at 1.5 megahertz. No, I do have the BIOS entry point. So let me just, it's been a really long time since I've actually run that command. And I tried it last time and didn't seem to work. So if I do, I have this load symbols. Let me see if I can just remember. It's been such a long time. Sometimes it's funny because I'm like, you know, if I want to know how I did it, I should just look back at some of my old streams. See, load user symbols file, and then what am I looking for again? Equals or equal, okay. And for the BIOS, I had, this is the listing. Is that the one I was using, or was I using the ASM? Oh no, sorry, I didn't want to do that. Yeah, 6809 was a cool chip. Actually, I don't know. Oh yeah, Lisp Gamer, yeah. Yeah, Lisp Gamer actually coded on the 6809. This is pretty cool. Alright, that's right. I was able to generate a symbol tables listing, but my code doesn't actually parse this, but I should totally make it parse this. But instead, what did I parse? Is it this? Oh, no, I remember now. Okay, yes, it's coming back to me. I have a file. Where is it again? No. Oh yeah, it's called include. Isn't it? Include.txt or something? What? Oh, maybe it wasn't called include. Oh, internal. This is the one. No, this is not the one. I'm trying to locate that. I used to have this file that had these .eqws in them. EQU, I mean. Where did I stuff that stuff? No, I mean, there isn't I'm not using like the proper, debugger symbol format. It's totally a hack that I put in place. Because I had initially this file that somebody basically extracted the BIOS and commented it all, and then had made a separate file. Yeah, it's like I lost this file. No, it wouldn't slow things down, and I would always have them, absolutely. So I don't know what I did with it, but basically, there's you see, if you run the assembler, and you can tell it, to this is dash T is like the option that says just dump the symbol table, and then this gives it a name, and then you feed it the ASM files to assemble. So this command that I wrote here went and generated this symbol table here. But I don't parse this format just yet, so I should. But I used to have another symbol table that I, for some reason, can't find, which is super weird. Just give me a second. I'll be right back. Okay, I located it. It's this file right here, vectrex.inc. So this is the file that I had and that I wrote my little parser for. It's right here. But yeah, I should totally, like, if I was to be able to parse these symbol tables, then any ROM that I could compile, I could load its symbols up, which is why I wanted to do it properly. Yeah, maybe I should do that. Wouldn't take very much. I think it would be as easy as doing that. And then let's see. Vectrex.inc. Yeah. So let's try that. Okay, so let's see if this actually would load my symbols. Okay, so let's see. Apps AAB and then F584. So that's what we should be storing. This should be correct. F584, yeah. Okay, well that wasn't very hard. So now apparently we have symbols like that. See, basically everywhere you see an address, if I resolve it to a symbol, I have this little you know, parentheses with braces with the name of the symbol next to it. Okay, so given that, if we go back to 3D Mindstorm, but yes, I don't load them up every time, and so I always found myself having to do it again and again. And I remember telling myself I should have like a debugger auto run script or something to do that. I think I have a to-do for that as well. Oops, let symbols like this. Trace. How do we refresh? Shouldn't it have detected that this file got modified on the outside? Like, what if I delete it? Okay, detect that. Now if I dump the trace out, wow. Yeah, this is where you see that Visual Studio Code can be a bit slow. Come on. There we go. Okay, so for example, here basically we have a loop that's constantly decrementing b and checking for not equal, so meaning we reached 0, to go to branch if not equal to FD. Yeah, so keep going, and then branch if not equal, then we come here. So what are we doing? We're saying load D with 0 EFF. Then we go to some sound function here. This is all music stuff. And then we come back to 0E20. Yeah. E28. So 0E35. Ugh. Okay, so here it's doing some DDR manipulations, data direction registers, which is probably where I'm failing to do something right. Thanks, Lisp Gamer. Take it easy. Have a good night, man. Great. Thanks, man. See you on Wednesday. Okay, so we clear the data direction register A. So let me see if I can refresh my memory a bit on this. Port A is connected directly to the DAC. So here I am looking at data direction A for whether or not to update integrators. So that's interesting, right? We want to make sure that we only update integrators if all the bits are set for, so we're only writing data, not reading. And yeah, I have this assert that says we expect DDR for A to be either all zeros or all ones. I don't remember why that's the case, but I guess I must have read it somewhere. Oh yes, so for reading from the digital joystick mode, it should be all zero. So maybe that's what this is about. Now we write E to port A. Why would this ROM store a value on the DAC for reading here? Normally when you clear the data direction register, it means you want to read on port A. Whereas now writing to port A will basically do nothing. Well, it'll store a value in there. Okay. Let me just remove the wrap. Is that Control Alt Z, was it? Oh no, sorry, it was off. Why does it look like this? Okay, that's just a decimal value. Decrement 3. Does this make sense? Decrement 3. Okay, no, okay, decrement at address 3, right. So this basically goes and now sets the data direction back. So I'm not quite sure what this code is about. We're storing 9 on port B. Clearing DDR again. Load B. Store FF into port B. Actually, this is a read, isn't it? Load B from the value that's in port A, which gets FF back from port A. So I guess this is about. This must be related to either audio or input. And then ultimately, when it's done, it sets back the data direction register to FF. Yeah, you're talking about this here, and sets the SNH at 0. Yeah, let me see. One 001, so it's gonna set sound BC1, was it? Port B gets 9. Yeah, I think it's setting mux disabled on, and it's setting sound BC1 to on. So yeah, this is definitely like sound related code, which I haven't implemented yet, which is why I'm not really doing anything with it. I have this to do. In this mode, we're reading the PSG's port A, not the VIA's DAX. This is probably wrong. I don't even know what I wrote here, but anyway. But I don't think this is where our problem is. Yeah, as we can see, like all of this is related to music. But then eventually we get back into this loop. It's always the same thing. Let me see now. So when we came back to here, we were at 0E35. 0E20. We go back into the sound byte raw. Wait. 0E2B. Music code again. Yeah, it looks to be a lot of music code. It's just like this infinite loop where we just keep going back and forth between same bits of code over and over. You know what, let me copy that. Let me open this in Visual Studio because I'm having a hard time manipulating this file. It's really, really slow. And hopefully Visual Studio will handle it a bit better. Yeah, it's exactly the same over and over. So I'm not seeing what it is that's stopping us. Here's just decrementing B, just like a wait loop. What could it be waiting for? F25B. So this is soundbite raw. Once again, F25B here. See if I can write a regex to give me what I'd like to see here. Will it find new line? Okay. Including the new line and then starting with, yeah, $sign F. So find that. Sorry, $sign has to be escaped. Okay, there we go. So if we find all of this in the current document, I'm just curious, is this the only function we ever call? Yeah, it is. Look at that. Basically, every time we jump into the BIOS, all we're doing is sending sound bytes, at least for this last 100,000 of amounts of trace. I could try to dump a bit more. I believe I have 1 million in there. Yeah, it is weird. I need to find what it is in here that the ROM is waiting for. So now let's tax Visual Studio on trying to load a 1 million line file. Still dumping. At least I think it is. Should be. Feels kind of strange that's not changing size here. Oh, you're right. Could be interrupt related. Could be interrupt related. Yeah, that could make actually that would make a lot of sense. Although I'm not sure which interrupt. Maybe. But normally, I mean, I have implemented technically the timer interrupt. I mean, it's more like a, not really a timer interrupt, is it? Let me see. Oh, this actually finished. Why doesn't it actually finish here? Anyways. Oh. Now we're at 0. It's true that there are interrupt registers on the VIA chip here. But I mean, I don't think that's what we're talking about here, because we would see it trying to read. Yeah, it's true that I haven't implemented interrupts yet, but I don't think that there is a interrupt that occurs on the timer, but I'd have to look again. I have a document that I was looking at that talks about interrupts. Just to be sure, let me just like see if I can open this. Oh, I think I see what happened. I kind of like cached. I had like somehow written enter. Oh, that's it. I had hit enter a few too many times and it was rerunning the last step. That's what was going on. In the meantime, let me see if I could find that document I was looking at. It was one of these ones, wasn't it? So yeah, there's something weird with my debugger here where for some reason it's not showing the prompt again, despite the fact that we're no longer like we're no longer dumping out here. So let's see what's going on. Or are we? We're stuck in set window title? All right. But you're probably right, Pyro. It's probably related to interrupts. I'll have to like actually start looking into that. So let me write that down here. Basically, I know what you're saying is probably there's like this is waiting for a certain interrupt to fire, and then there's some code in the interrupt handler that'll get things started for this 3D Mindstorm. You know, and that would make sense because the version B1 here, although the version B1 actually is a via not implemented, I get, which is read interrupt enable not implemented. So it's checking for interrupt enabled there. That's interesting. So yeah, maybe it is a VIA based, not a CPU based interrupt. I need to read more about this. So there are interrupt flags related to the timers, but those I always set. Well, I mean, I set if the interrupt flag gets set. Because basically it's like a polling based system for the timers. You just check bits on the interrupt flag register. just gonna do this check on this million line file here. Yeah, so look, from what I understand, when it comes to the VIA, in terms of interrupts, it's just in the end you just want to be polling for bits, and there's no like actual interrupt vector. The only place where there's interrupt vectors are for the CPU. So if I could just find that document, we can actually take a look at the interrupt table and see if there actually is something in the ROM. It's totally possible. So where was I? Yeah, I was here. Okay, here we go. Yeah, so same deal it seems. No, looks like I didn't make it to 1 million, but anyway, I had to cut it short. There was something weird with my logic for dumping to the file that seems to have messed up with it gets like stuck or something. Alright, so probably interrupt not being handled. So let's see here. I go back to okay, so here's the interrupt table. So I mean, I haven't read too much about this, but I don't think there's an interrupt here that occurs on its own. I think these have to be, am I wrong? I think all of these have to be invoked. I'm probably wrong. Let me go take a look at this ROM. 3D Mindstorm. Oh, that's right. It's not the ROM that controls, that sets these up. It's the BIOS ROM. Yeah, let's say these things are fixed, as far as I know. If we go to the BIOS ROM here. In fact, let's look again at the source. I think it's right at the end of it. Okay, here. So yeah, so the reset vector is the one interrupt that I do obviously follow, because basically when we start, that's what I do. I jump to wherever the reset vector is pointing. But then here we have CB, FB for SWI and NMI. But these I think are invoked, right? Let me see. They come from the cartridge? So when you say they come from the cartridge, you mean like there's a CPU instruction? Ah, yes. The schematic. It's hardwired. But then what would cause it to trigger those interrupts? Okay, so that's reset. Yeah, I read something about the FIRQ in terms of the controller. I think the second controller can trigger it. So maybe that's what I'm missing. So what I wanted to check was, let's say we were to look here. What are these pieces of code doing, you know? Okay, that's it. So oh, I see. Okay, so these are the addresses at which the ROM would set, you know, what to call. So I should take a look at these addresses in the ROM. No, I am not Romanian. My family is Italian, although I am myself Canadian, but yeah, ancestry is Italian. So let's see, SWI3 here. You're saying SWI3, it looks like it's connected to SWI3. So let's see, SWI3 is written in, so SWI3 and SWI2 both, either one is at CBF2. I have an accent, you say? I'm in Montreal, Quebec. Oh, SW3. So what's SW3? What are we talking about here? You mean the input on the controller? Oh, you're in Ontario. Okay, cool. It's not too far away. Oh, welcome, Celis. So SW3. Okay, so you're saying SW3 is connected to the joystick? It probably represents like one of the buttons or something. I'm not sure where I'm looking here. Is it down here? Here maybe. Switch 4, 5, 6, 7, pod 2, 3. Switch 3 here. I assume that's what you're referring to on the right controller. Switch 3 is connected here into IO3. On IC208. Yeah, here, right? So that's, man, I have to say, this is a pretty bad quality scan here, eh? If you follow the wire from switch 3, it goes back to FIRQ. You mean this way? See, FIRQ is where? Here is IRQ, NMI. FIRQ here, okay. Oh yeah, there you go. Try something. Trying to use this tool I have called Green Shot. It's got a cute little highlighting thing in there. I'm wondering if it's going to work well for highlighting this. Otherwise I can try to use Paint.net. Oh, this piece of crap. Why doesn't this ever work? See if I can make this work. Which one does alpha here? Is there not like an alpha blend for this? Here, it's here, blending mode, okay. There we go, multiply. All right. Check out these mouse drawing skills. There we go. And I'll say, this one, Pyro? Okay, so yeah, I wanted to check, oh yes, I was gonna check to see FIRQ, right? So let's see what's at CBF5, just curious. CBF5, because you know we could try something kind of cute. Let's see, before I get too excited. So CBF5, address invalid. Yes, that's because, why is that? Is that just in RAM? Okay, let's see. Actually, I guess I can just read it here. Read, is it read? Print, P, right? CBF5 and CBF6, EE32. I guess that makes sense. EE32. No, does that make sense? No, doesn't really make sense. I don't think there's much in a Vectrex cartridge. I mean, unless, you know, somebody builds a custom cart, but I mean, the normal carts don't really have anything special. Just check again. CBF2. Why does it say 3 bytes? Why would it be 3 bytes? 3 bytes. Where did I put that reset code again? So it's 3 bytes, but it looks like the first byte, I'm not using it. For example, for reset, it's FFFE and FFFD, but here it claims, sorry, FFFE and FFFF, but it says that it starts at FFFD for the reset vector. So I'm not quite sure what the deal is with having 3 bytes for that. Okay, so let's say it's just the next 2 then. Does it make sense? 3264. Well, 3264 would certainly be in cartridge space, right? Maybe it makes more sense. 3264. Invalid cartridge read. So it's supposed to be in user RAM. So by this point, we would expect that the user would have written the vectors that it wants us to jump to for each interrupt into these addresses. Let's check the other ones, see if there's anything more sensible. What about CBF2? One thing we could do is we could look for, was it if I do a watch What's vec cold flag? Okay, that's something else. Okay, so I put a watch point on all the so all the RAM locations where vectors, like these interrupt vectors, would be written to by the ROM. So let's see if it actually writes. Ah, okay. So we did hit. Watch point hit at CBF8. So CBF8. So that's interesting. Okay, so it's actually writing a value to the IRQ vector. Write value 7E. Oh, and here we wrote some more. So we've written only one byte to F8. And then we wrote finally another one to F9. So actually F8, F9, right? So that would... F8, F9, and FA. So 0E5A. That seems like... Let's see, where are we right now? E5A store D. So this is it. This is some code that says we're going to store into the vec IRQ vector 7E, which is the first one, but then for some reason, okay, and then we do this store B to the interrupt enable. Oh, that's interesting. Why didn't I see something related to that? Storing a value into the interrupt enable. Oh, that's it. Huh. Why did I take this off? Okay, so there you go. I thought I had not commented this out. That I was expecting to see this message if ever a ROM were to try to write to interrupt enable on the VIA, because clearly I'm not handling it, right? But I guess at some point I must have commented it out because it was causing me errors, but that obviously it's important here. So this is an IRQ probably that is set, like comes from the VIA. And then the address that it writes is OE5A. So that's, you know, if I could set my PC to OE5A, we may be able to move forward. Yeah, I don't have a way to do that from my debugger, but I can do it in code. So let's try that. OE5A. That's just like, I don't know when I should do it though. I should do it from a safe place. Let's see, if we go back to my, if we do like okay, let me just take some notes here. For 3D Mindstorm, stores 0E5A. IRQ vector, and then actually what does it set here? It sets 82, also sets 82 on via int enable, so probably interrupt is enabled on via. We can actually go look at the schematic. So is it, if I'm reading this right, it looks like it's, could it be that it's coming from here? Or is this like the clock here? Not sure I understand what this means. The cartridge pin 36 seems to be able to write IRQ, if I'm reading this right. Volts. BC2. What is BC2 again? I need to check this again. The resistor is just a pull up to 5 volts to keep the IRQ high. The VIA 6522A has an IRQ2 on the opposite side of PAX. Oh, here. Do you mean here? The IRQ fires with a logic 0. What do these chips do here? All these ones that seem to be between the CPU and the VIA chip. Whenever you see a pin name with a dash on top, it means it's driven with logic 0. Huh. Okay, well, I'm not quite sure that I understand, but I mean, what I do understand is that something needs to trigger this IRQ, right? The Vectrex service manual has a block diagram. Where is it? This? .204 and 205 is static RAM, and 201 is exec ROM. Trying to see, like, here, what is a 2363? Oh no, that's it, that's the IC201. Oh, okay, I was looking at the wrong numbers. IC201, that's the exec ROM, I see. And 204, it's here, static RAM, and then 205 is this here, and then 207. Okay, that's our VIA chip here, and this is like the sound chip. Okay. But so this IRQ here, would it necessarily have to come just from the cartridge for this to work? Or like the rest of the image? Yeah, that's what it looks like, right? And even here, no, not here. Here, looks like it comes from the cartridge as well. But then there comes the question, like, what triggers that IRQ then from the cartridge? Anyway, just for fun, you know, it's probably not going to work. Let me just see if I were to let me dump a trace of, let's say, so actually here we are checking for if a bit is set in the interrupt flags. I just realized that. What is this? Why didn't I see this before? What the? Oh no, okay, I know why. This is just too early. This is, okay, sorry. What we're looking at right now comes from when it starts. We need to let it run for a little bit. Okay, it's running now for a little while. Now if we dump our trace, we'll go back to what we saw before. What we were looking at there was some bootstrap code from the actual BIOS. Okay, so this comes back to where we were doing our decrements and sound byte raws and all that. So let's say at this point, just to be safe, before we do this jump to the sound byte raw, yeah, got a little excited there myself. All right, so let's say we put a breakpoint. Okay, so we're at 0E28. Now this is probably not going to work, but let's try it anyway. Let's go to CPU. Oops, execute. Instruction. And let's overwrite our PC. It's not PC, it's something in my registers. Here. So instead of 0E28, let's force it to go to 0E5A. Yeah, 0x0e5a. Alright. Okay, so in that interrupt routine, it went and wrote again to the interrupt vector table. Oh, look at that. We got something. And now we're at invalid cartridge read hell or something. But we saw, look, there's some graphics on screen. And then we even get a no, but then we start reading at invalid addresses. So this definitely is going in the right direction, right? It's kind of cool. Just by forcibly jumping to where the IRQ would normally send us, we actually got something. So yes, you were right, Pyro. This is related to interrupts not being implemented at all. So I just need to kind of read up on that and figure out how that works. Okay, I think I'm gonna stop here. So yeah, thanks for watching, guys, and I should be back in a couple nights. Thanks again, Pyro. Take care.